Okay, yes. Good afternoon, all. Yes, very good afternoon. So we will continue there. Yes. Okay. Lastly, we discuss. We will continue from that one. Okay, quickly we will move. I last day, as I remember, did you remember? I just started. We draw these figures and all things. I just started. What are the cores, cache, and the internet clock? Okay, just started that one. We will now consider the factors that determine the performance of CPU. So the first thing, the role of the system clock. So there should be we have to we have to know what are the main things that you have to determine when you are following the CPU. So there should be main thing. The clock define the clock cycle that synchronize the all computer operations. You should be know what is the clock and what is the clock cycle. There should be what define all synchronized operations. As mentioned earlier, the control bus that transmit what timing signal ensure everything fully synchronized. Okay. And next thing, by increasing clock speed, the processing speed of the computer is also should be increased. Actually, as we discussed right last day, actually that clock speed should be when this clock speed increase the speed, it can be speed the computer process speed. Okay, that actually 3.5 gigahertz means that 3.5 billion of clock cycle for 1 second can be terminate 3.5 billion of clock cycle for 1 second. Although the speed of the computer may have the increase, can be increase the speed of the computer also. And it isn't possible to say that computer overall performance. But it can be isn't possible to say that computer overall performance is necessarily increased by using the higher clock speed. And other factor need to consider, for example, something like what the width of the address bus and the data bus we already consider. And the next thing is the BIOS. This is very important. We are writing now. Yes. Yeah, these are important. That's why we are writing there. Okay. So next thing it should be what overlooking factor is what the BIOS. The second overlooking the factor of consider the clock speed can be changed by the accessing the BIOS and altering the setting. This is very important. That clock speed can be changed with what? This accessing of BIOS. That accessing of BIOS. That basic input output. The overlooking factor of consider the clock speed can be changed by the accessing the BIOS, that basic input output system, and altering the system. Okay, that also can be happening here. Okay, can you write down that underline part? With BIOS, it can be changed. It can be changed. Accessing this. Yes, with BIOS, it can be changed. Definitely can be changed. You see, BIOS, it can be what change the overall computer. So, however, using clock speed higher than the computer was designed for lead of the problems. It can be designed for the lead of the problems. That can be, for example, the execution of instruction. Okay, it can be designed but lead of the speeds. So it execute the instruction outside what? Outside limits can be lead seriously one unsynchronized operations. It can be seriously going with the unsynchronized operation. So an instruction is unable to complete in time before next one is due to executed. So the computer would be frequency class and become unstable. Okay. And all locking can be lead to serious overheating of the CPU again leading the unreliable performance. With unreliable performance, that execution can be okay with that one. Okay. So it can be following up with these things. Okay. Execution in the instruction and all of it can be laid to serious overheating in the CPU again. Okay, so and because of that one, because of I don't write all these things on okay, so it can be what limit the speed of the computer. However, so and the next thing, the use of cache memory. The use of cache memory can be also improve the CPU performance. Unlike RAM, the cache memory is located with the CPU itself. So which means it has much faster data access time with the RAM. Okay, cache. Cache is the smallest memory that can be seen on the CPU. So cache memory, using with the cache memory can be also improve the CPU performance. So unlike with the RAM, cache memory is located within the CPU itself. So cache memory located CPU itself. But RAM, it's separately placed. But in the cache, it should be placed inside the CPU itself. So, which means it has much faster data access time than RAM. So it can be have much faster data access time, but rather than what RAM. So cache memory is stored frequently used instruction and data that needed to access faster. Okay, so actually it's which improves CPU performance. So cache memory can be because of that turn. Cache memory can store frequency use instruction and data that access faster, which improves CPU performance. So can be improve CPU performance by using the cache memory there. Okay, can you write this underline class, please? I will give time. Okay, underline part, please write down that. Okay, so use the cache memory, it can be improve the CPU performance. Okay, write it underline part is write it. Okay, right. Yes. Right underline first. Yes. Okay. Okay, right like that. Okay. Yes. Okay, like that one you can use a cache memory for perform RAM. When you wanted to perform on the RAM, you can use the cache memory there. Okay. Yes. The performance on the RAM, you can use cache memory on that. Cache memory store frequency use instruction and data that need to access faster, which improves CPU performance. Which improves CPU performance. So when CPU wish to read memory, it will be first check out the cache and then move for the main memory like that. And also the next thing, I, last day also I said this one. Did you remember the use of the different number of cores? Sometimes single core, sometimes dual core, there are quad core. Okay, improving by generation. By generation, it become improving. The use of different number of core definitely improve the computer performance. The use of different number of cores can be improve the computer performance. It can be improved. Okay, use of different number of cores can be improve the computer performance. So one core is made of ALU. Okay, the one core it's made up with ALU, that arithmetical logical unit. Uh, Control unit and the registers. Okay, one core made up with the ALU, a control unit and the register. Many computers are dual core. Normally, you can see made up with the two cores. And quad core is made of the four cores. You can see, you heard that latest one is a quad core. It's made up with the four cores. Okay, so idea of the using more cores, it's elevates the need of what continually increasing clock speed. So, however, when you are using more clocks, more cores, it can be definitely, it can be definitely, but increasing, continuously increasing clock speed. It should be, however, it can be increase the clock speed when you are using the cores, okay? Increasing the number of cores, okay? Single core, quad core, sorry, single core, dual core, or quad core, okay? Like that one, it can be increasing, okay? Okay, write down. Write this underline part, yes, write it. So you can see here having example for that one. Okay, for example, so with the dual core, CPU communicated with the both cores. I said they are having dual core, they are having two cores. So with the two cores, it can be what working with the two cores, with both core using the one channel. Okay, reduce somewhat of the potential, increase the performance. Okay, now if they are having two cores like here, one and core two, it can be working the two cores in the same time, so it can be potentially increase the performance. And the quad core, what happened? There are only one channel. You can see connection of the one channel in the dual core. Look at here, quad core, how many connection there? It's better to draw this figure. You can clearly get the idea. Okay, while with the quad core, CPU communicate with the all four core. Uses six channel, considerably reducing the potential performance. Okay, with the quad core, there are considered four channels. Like here, it can be consideration of the four channel. Now each and every channel are get connected. Each and every channel get connected. They are having six ways to connected with the channels. They are having six ways to connected with the channels. So there are we call it six channel. So it's more increasing compared with the dual core. Compared with the 12 core, it's very increasing. That's the differentiate between the quad core and the dual core. That's why it's very increasing. Okay. Can you write down that? It's better to draw the figure. You can get clear idea with the differentiate of the dual core and the quad core. You can get good idea when you are drawing that. Okay. Please draw the figures it better. Okay, write it with the drawing figures. Okay, write it, drawing figures. Okay, you can write like that. Yes. There I have it word code and the quote code like that. Okay, so there are two options like that. Value, but increase in the that quad like here, it's increase in channel. Because of that only you can what increase your processing speed. So all these factors need to taken what account when considered computer performance. So summarizing these points, you can take what increase bandwidth, the data and the addresses, increase the performance of the speed, and increase the clock speed. It potentially increases the speed of the computer. So this is very important. This is the important part. That's the summarization. What is that? So all of these factors need to taken into account and consider computer performance. Summarizing this point, when you summarize this point, increasing bandwidth, data and the address bus, increase the performance and the speed of the computer system can be increase the performance and the speed of the computer system. Other thing, increasing the clock speed with the potential increase speed of the computer. That too, very important. Okay. So, and the computer performance can be changed with the all-tree budget clock and they use a multi-core CPU. There can be used more multi-core. With the multi-core, it can be used more channels. So use of cache memory can also speed up CPU performance. That are the very important things. So these are factors that can be should be finalized. Okay, what are these? Please write down that underline these. What are these? So all these factors need to take into okay, right quickly. So all these factors need to taken into account when you consider computer performance. So when you summarize that points, what are the increase in bus width? Actually, with the data and the address buses, it increases performance and the speed of the computer system. Can be increase the performance and increase the computer system. And increase clock speed will potentially increase the speed of the computer. Clock speed can be potentially increase the speed of the computer. And computer performance can be changed by the altering bus width, the clock speed and the use of the multi-core CPU. And the use of the cache memories can also speed up the CPU performance. That are the things that can we should be following up. So okay, please write down them quickly. After that one, I will know enough for today. Okay, write it. And that should be the summary of the whole things. So increase the bus width, increase the clock speed, the computer performance with the course, and the use of what cache memories, use of the cache memories. Okay, that are the things. Yes, that should be the summary of all. Yes, that should be the summary of all. I guess you got the point. Yes. Okay. Yes. So I think you already wrote that this law. Yes, you can write. And after they are having activity for you, try to do this one at home. Okay, try to do this one as homework. Okay, I think it's almost time up for today. Yes, yes, it's almost finished. No, yes. So it's almost time up for today. So I will wind up for today. Yes. So we will discuss other thing on the next day. Okay. Yes. So we will discuss other thing on the next day. So see you next day. Okay. Good afternoon all. See you next day, buddy. Bye. See you next day.